Today's episode is another step outside the book Switch to apply its concepts in software engineering organizations. I'm going to talk about ways to script the critical moves in a software engineering practice called refactoring. Refactoring is a software engineering practice in which you make improvements to the design of a piece of software without changing its functionality. The reason you'd want to do this is to reduce what is called technical debt. Technical debt makes it hard to add new functionality or fix bugs in a piece of software. Ward Cunningham describes technical debt as the accumulated distance between your current understanding of the domain and the understanding that the system reflects. Here's Ward Cunningham.
A lot of bloggers, at least, have explained the debt metaphor and confused it, I think, with the idea that you could write code poorly with the intention of doing a good job later and thinking that that was the primary source of debt. I'm never in favor of writing code poorly, but I am in favor of writing code to reflect your current understanding of a problem, even if that understanding is partial.
Michael Feathers uses a different definition that defines technical debt in relation to features and emphasizes refactoring before adding a feature, rather than treating refactoring as cleanup work. Here is Michael Feathers.
The refactoring effort needed to add a feature non-invasively. So there's some subtleties here, right? I'm not talking about general things like going and working against a measure of design principles and all this other stuff. What I'm saying, though, is that in general, in good code, it should be possible for you to go and add in a feature without going and mucking with things too much, right? And this kind of points to a particular approach that you can take when you're going and adding features in. What you can do is you can say, I need to go and add a feature in. So what I'm going to do is I'm going to go and sit down, look at the code, and I'm going to refactor it to the point where basically the addition of the feature is easy.
So how do we produce a change, going from software engineers who don't refactor as part of the work of delivering features to software engineers who make refactoring a part of delivering a feature every time it's needed? We need to make it clear when and how to do refactoring. We need to script the critical moves. First, be clear about how people should act. Our old friend test-driven development helps us with this because it says, write a failing test, make it pass, and then refactor. It is very clear when you need to refactor. Second, pick one place to start. You may have a code base badly in need of refactoring pervasively, but where do you even begin when the problem is so large? You also need to have a goal when you refactor, or else you'll be asking, what is driving this process? Putting a story in your backlog whose only purpose is to refactor some module is going to cause you problems here because the business value is not obvious and you aren't providing direction. Instead, make refactoring part of your next feature. Third, if you can't nail it exactly, consider the best approximation. You don't always get to make the code perfect in the module you refactor. Maybe there isn't enough time, or maybe you don't understand the problem well enough yet. Instead, focus on what gives you the largest benefit for the time invested. If you're adding a new feature to improve throughput by making something that was single-threaded multi-threaded, you might have to do a refactor to eliminate some shared state. Maybe you can't eliminate it all and have to settle for putting some kind of mutex around the remaining shared state. Let people know that refactoring isn't about achieving perfection. Fourth, kill the abstractions. Not everybody can name all the solid principles or can identify every possible code smell. Describing refactoring in these terms is too abstract for your audience this early on. But thinking in concrete terms, software engineers know when a design makes multi-threading difficult, or when a class becomes too bloated with collaborators, or why global variables and other forms of shared state make maintenance difficult. Starting with these concrete examples that motivate refactoring, you can begin to demonstrate the benefits of slowly chipping away at technical debt on each and every feature by incorporating an appropriate amount of refactoring. Fifth, go back and evaluate your critical move candidates. Evaluation question number 1. Does it evoke emotion? I don't know about you, but I can get pretty frustrated dealing with a code base when I'm trying to add a tiny feature and I can't because the code surrounding it is so poorly factored. Working in a well-designed code base, by comparison, is bliss. Question 2. Does it feel doable? Again, this is where you want to scale back the challenge to what can be accomplished while delivering a single feature. Don't refactor the world when changing the color of a button on a form. Some code bases have accumulated so much debt that refactoring them is intimidating to the inexperienced. For someone new to refactoring, a smaller, newer code base that hasn't yet racked up so much debt may give them something to practice on. Question 3. Was it part of success stories in the past? This is where your bright spots come in. As in the TDD example, people in your company who've improved tech debt on their projects can share stories and tips that your team may be able to relate to. Question 4. Will your team see connection to the big picture? This is why refactoring needs to have a goal. What is tech debt costing you today? Can you quantify how many times a story took longer to finish because of tech debt? Get your team to imagine how much easier it will be to add features in the future when tech debt has been addressed. Question 5. Would it provide a quick win? This is why small refactorings are best at first. Large refactorings require significantly more skill and more advanced practices, like the Mikado method. Question 6. Would it create positive peer pressure? This depends on how much your coworkers interact with each other. If they share the same code base, one engineer's refactoring will be appreciated by the others. They can also hold the other engineers accountable for not letting tech debt grow. Finally, is it consistent with the way people think about themselves? Maybe not at first, but as the opinion leaders on your team start to adopt refactoring as a part of their daily practice of writing new features, the rest of your team will follow. Most engineers like to think of themselves as skilled practitioners. The more refactoring is considered a fundamental skill of a software engineer, the less acceptable it will be to lack this skill. So that's my attempt to apply the concepts of scripting the critical moves to make refactoring a regular part of feature development on a software engineering team. In the next episode, we will examine the third technique in directing the writer, called pointing to a destination.